Hi all, I am Divya Somakumar and in this video we are going to learn an ensemble learning technique which goes by the name ADA boosting or ADA boosting. Now let's understand what exactly is ADA boosting. ADA boosting stands for adaptive boosting. Now what exactly does adaptive boosting do? It helps us combine multiple weak classifiers into a single strong classifier. How does it do that? It does that by putting more weight on mispredicted instances than on correctly predicted instances. ADA boosting can be used to solve both classification problem and regression problem. Now let's understand the working of ADA boosting. Consider the following dataset. You have x1, x2, x3 and y. Now we are going to fit a model. After fitting a model, we will get the slope. And all the slopes after fitting the first model is written on the right hand side corner. Now there is a problem in this case. What is the problem? Two observations were misinterpreted or mispredicted by our model. Three observations were correctly predicted by our model. Now, we are going to see how ADA boosting works. We will learn what is misinterpretation rate. Misinterpretation rate is the number of times our model has mispredicted the data upon total number of observations. Now, this is our misinterpretation rate, which is 2 by 5, which is 0.4 in this case. Another concept that we have to learn is stage. Stage is given by natural log of 1 minus m rate. M rate is nothing but your misinterpretation rate upon m rate. In our case, our stage value is 0.4. Now, our new weight. Our new weight is nothing but our old weight into e raised to stage, which is 0.2 into e raised to 0.4 and it is 0.29. Now, this new weight is only for those classes which are misinterpreted. So, all the classes which were correctly interpreted will continue to have the same weight, 0.2. But the two classes where we have misinterpreted will have a weight of 0.29. Now, if you observe, all the slopes were adding up to 1. But in case of new slope, our slopes are not adding up to 1, they are adding up to 1.18. Slopes, weights and probabilities are very closely related topics, and as probability lies between 0 and 1, our slope value or adding up of all slope values should also be less than 1. So now we have encountered a problem. How do we solve this problem? We solve this problem by standardizing our slope. Now let's add up all the figures. We get 1.18 and then we will divide each and every new slope by the total amount. So we get this. So 0.2 divided by 1.18 is equals to 0.16 and then again 0.16 and 0.29 divided by 1.18 is 0.24. Now these values will add up to 1 over here. Remember that whichever class was misinterpreted, it is going to have a higher weight now. So that next time when you train the model, these guys will be correctly interpreted. And whichever classes were correctly predicted, they will have lower weight. Now, let's look at the Python code for ADA boosting.